So hello everyone, today we are going to solve this problem musical chairs. In this problem we are given that n friends would decided to play a game of musical chair. Initially they decide a number k and with each passing round they remove exactly k chairs. Hence in each round exactly k players are eliminated. What does this mean? This means that in the initial round, in let us suppose in round 1 there are n number of players. Then in round 2 there will be n minus k number of players, and in round 3 there will be n minus 2 into k number of players, and then so on, and then until the game stops when less than or exactly k players remain in the game, which means that this number becomes less than or equal to k, we will stop. If it's greater than k, we will continue to the next round, otherwise we will stop the game. And then what we have to calculate, chef wants to figure out for how many possible values of k there will be exactly one winner in the game. We have to calculate all possible values of k such that this value will be equal to 1. We have to calculate all possible values of k such that the remaining number of players in the final round will be equal to 1. Now let's look at the first test case. In the first test case, we are given n equals 2. So let us suppose we choose k equals 1. So in round 1, there are n number of players, that is 2 number of players. Then this number is greater than k, so we will continue to next round. Then in round 2, there will be 2 minus k, that is 1 number of player. This number is smaller than or equal to k, so we will stop here. We will calculate. Now we can see here that the remaining number of player in the last round is equal to 1. So we can take this value of k in our answer. So our answer equal 1. Now let us suppose we choose k equal to 2. Then in round 1 there will be 2 number of players. This number is not greater than equal to k. This is smaller than or equal to k, so we will stop here. And then we can see that the number of players left is not equal to 1. So this value of k cannot be included in our answer, and answer will remain 1. Now let us suppose we choose k greater than equal to n. That is, if we choose k equal to 3, we can see that we cannot move further from the round 1, because in round 1 there will be 2 players, which is always going to be less than or equal to k. So we are always going to stop in round 1 itself. So we cannot choose k which is greater than n, and the number of players remaining in round 1 are 2, and we want exactly one winner, so this case also cannot be included. So we cannot take count of k which are greater than equal to n. So let's discuss the second test case. In the second test case, we are given n equals to 3. Now in the first round, if we choose k equal to 1, in the round 1 there will be n number of players, that is k, which is greater than, that is 3, and which is greater than equal to k. Then since it is greater than k, then we will move on to round 2. In round 2 there will be 3 minus k, that is 2 number of player left, which is still greater than k, so we will move on to the round 3. In round 3 we will have 1 player remaining, which is smaller than or equal to k, so we will stop here, and we can check that we have exactly 1 player remaining in the last round, so this k can be included in our answer. If we choose k equal to 2, in round 1 there will be 3 number of players which is greater than k. So we will move on to round 2, and in round 2 there will be 3 minus k, that is 3 minus 2 which equals 1. One player remaining which is smaller than or equal to k. So we will stop here. And as you can see, we have exactly one player remaining, so this k can also be included in our answer. And now k, we cannot take count of k equal to 3 as this is equal to n. Suppose we take k equal to 3, now the round in round 1, suppose that we are given number of player equals n. So what we can see from the test cases is that there should be exactly one player left in the game. Suppose that n equals 7. So these are the number of players. Then let us suppose that 7 will be the winner of the game. Now in each round we have to remove these 6 players from the game. We can remove them in a single round, or in 2 round or 3 round, and or in multiple rounds, but there should be exactly 6 players removed from the game such that there will be only a one player which is 7. So how we are going to do that? Suppose that we choose k equal to 1. Then in that case, these are the number of players. We have excluded 7, so we have to form a group for these 6 players. Suppose in first round 1 is removed, in second 2, then 3, and then 4 is removed, then 5 is removed, and then in the 6th round 6 is removed, and in the 6th round itself we have a winner which is 7. So this k satisfies the condition that we have exactly one winner. Suppose that now we choose k equal to 2. Now for our players which are numbered from 1 to 7, and 7 is the winner of the game, let us suppose, then we have to remove 2 players in each round. Let us suppose in first round these 2 players are removed, then these 2, and then 5 and 6, and then in this case also we have exactly one winner remaining which is 7. So this can also be included in our answer. Let us suppose we have k equal to 3, and these are our number of players. 7, we are excluding 7, we are excluding the last player. Now we form a group of 3 people, 1, 2 and 3, and then 4, 5 and 6. Now we also can see that there is only one player remaining which is the winner of the game. So this k equal to 3 also satisfy our condition. Now for k equal to 4, we have our players 1, 2, 3, 4, 5 and 6 and 7. Let us suppose we have 7 is our winner. Then in the first round 1, 2, 3 and 4 will be removed, and in the second round these 3 numbers will be remaining, and we cannot remove 4 elements because we have only 3 elements left, and we cannot remove 4 elements from them. So we stop here, and we can see that number of players remaining is 3 which is not 1, so we cannot include this k. Now for k equal to 5, we have 1, 2, 3, 4, 5, 6, 7. 7 is our answer, we are excluding 7. And then we will form pair of 5 elements, 5 players, 1, 2, 3, 4, 5, and then 6 and 7 are left. Since there are 2 players left, we cannot include this k in our answer. So k equal to 5 cannot also be included in our answer. For k equal to 6, we have our players numbered 1 to 7. In the first round there will be 6 players removed, and in the first round itself we have 7 as our winner because 7 is the single player remaining, the single winner remaining. So k equal to 6 we can also include. So what we can conclude from this observation is that for all k which divide n minus 1, for all k which divide n minus 1 such that n minus 1 modulo k equals 0, we are getting our answer. Else we are not getting our answer. So in the when k equal to 1, since 1 divide n minus 1 which is 6, so we are getting our answer. 2 divide 6, we are getting our answer. 3 divide 6, we are getting our answer. Then 4 does not divide 6, so we are not getting our answer. Then k equal to 5. It's just that we have to form group for these n minus 1 players. So we are forming a group from these n minus 1 players of size k, and we can only form a group of some size if the number of the total overall size is divisible by our group size. So overall size is n minus 1 and the group size is k, and if k divides n minus 1, then we can say that this k will be included in our answer. So for k equal to 6, this divide n minus 1 which is 6, so this is also included in our answer, and this, and then so on. So what will be the algorithm for this problem? The algorithm for this problem will be, for each I equal 1 to I less than or equal to I less than n, we have to check if this I divides n minus 1. If this I divides n minus 1, then we will include this in our answer. We will increment our answer. So for each I from 1 to n minus 1, we will check if this I divides n, and then we will increment our answer. But if we place a simple for loop for this iteration over n players, then this will be very large, as our n is ranges from 1 to 10 raised to the power 9. So O of n solution is not going to work here. So what we can do is, we can simply traverse from I equal to 1 to I less than or equal to square root of n. Since all the factors which divide n will be less than or equal to square root of n, so we can just calculate the number of factors in square or in root n time. So now our equation reduced to I less than n to I. This is the C++ implementation of the solution. We are taking n the number of players as input, and then we are decrementing it because we are keeping track of only n minus 1. Then we are traversing from I equal to 2 to square root of n, and we are keeping track of if I divides n. If this is the case, we can divide n in the subgroup of size I. So we will increment our answer. This I will be our valid k, and then we are also checking if n divided by I, this element also divides n. If this element also divide n, we are also incrementing our answer. We are also checking the condition if we don't calculate the answer for the same element twice. So we are also checking temp should not be equal to I, and then at the last we are outputting our answer. So this is the solution, C++ implementation of the solution. I hope this approach is clear to you, and thank you.